Good day, everybody, every student of Thammasat University who study in the subject of Physics Laboratory 1 and Physics Laboratory 1 for Engineer. Today, I will describe about experiment 6. This is experiment study about the modulus of rigidity. In the first, I will describe how to define the modulus. What is the modulus? The modulus is the ratio of two quantities, stress divided by strain. Strain, where stress is the force per unit area of the material, and strain is the ratio of the change length when there is the external force applied to the material to its the original length of the material. When the external force applied to the material and the material to change the body, strain equal to the change length and divided by the original length of the body or of the material. The ratio of state and state is called that the modulus of rigidity of the material. The unit of the modulus of rigidity is the Newton per meter square. In general, there are three types of modulus. The first is the Young modulus. The second is the bulk modulus, and in the last form, is for to measure in the to determine in this experiment is the shear modulus. In this experiment, we concentrate to determine the shear modulus of the two types of the materials. Is the steel and brass. Okay. The shear modulus characterizes that when we take the force to shear the body and the body to remain in the original size. Okay, under the force taken by the weight of the test mass. Okay, you can see that by the definition of the shear modulus. See in the backboard, the shear modulus is the ratio of shearing stress divided by angle phi. Angle phi is called as the shear strain. You can see in the backboard of the picture when the our rod is taken by the external force and the rod is shear. You determine the shear angle phi is the ratio to the angle alpha. Alpha is the real shear angle. When we take the wheel to measure the shear angle, the measure angle is angle beta is related to the angle alpha. You can see the proof in the laboratory direction in the book, in the laboratory book. Okay, and we find the relation between angle beta and the load mass with to take on the rod to shear of the rod. Okay, you see the relation between the shear angle or twist angle and load mass by in the equation. Twist angle beta equal to the 316 G R L divided by pi square A square eta. G is the gravitational acceleration equal to the 9.8 meters per second square. R is the radius of wheel. L is the length of the test rod, which you find the shear modulus. Pi is the quantity pi you can see in your out calculator, and A is the radius of the rod we will measure and we will see in the experiment part. Eta is the shear modulus which we want to find in this experiment. We measure the twist angle which are related to the load mass and plot the graph to find the relation between the twist angle and the load mass. From the graph, you should find the slope of this graph, which is the ratio of delta beta divided by delta m. When you get the slope of this graph, you can determine the modulus of the rod or of the material. It means that you should plot the graph before to find the modulus. Okay. And you use the variable that measure in this element to calculate the modulus. Don't forget the unit of modulus is the Newton per meter square. This is a theoretical part. In our experiment, you should find the modulus of the stress. You should find the modulus of the brass and steel. Okay. Okay. We will describe in the experiment part. In the determine the modulus of rigidity of two types of material. This is the brass rod and the steel rod. You can see the instrument on the table. The instrument on the table, there are the wheel or the pulley which has which attached with the wooden strip, and screw with the attached attach the wheel. Okay, everybody. You can see the instrument to determine the quantities which is need to determine the modulus of rigidity. For the first instrument is the vernier caliper, which is used to measure the radius of rod. The second is the outside caliper, which is to determine the radius of the wheel or pulley. The third, this is the load mass, which are used to determine the twist or the shear angle. Okay, everybody. In the first, you should take the brass rod. You see on the brass rod, there are the mark at the end of the rod. Should take the end of the rod to take in the outer of the wheel. You see that the mark we put in the wheel or in the screw. The mark is you should adjust the mark to the same position to the screw, and to rotate screw to attach the rod. Okay, and in another side we will do the same again. You do see that under the screw, which should have the wood strip is the same on the wheel. Okay, it's same the wheel. The mark of the rod and the screw should be the same position or the same line, which is so that to lock the screw can lock the screw. We lock the screw, and now tie or expand the outer rod to the same line, and measure the length of the rod from the end to the end in the line, in the stanch line, only in the stanch line. It means that since that we should to take the rod to the end of the mark in the same position. And now we will measure the length of the rod. You can use the ruler, take the ruler on the rod. You can see the unit on ruler is the centimeter. For the example on this rod, we have measured in the 96.7 centimeter, and you should change the unit to meter. Centi is equal to the 10 power minus 2. It means that from the change unit from centimeter to meter is the 96 for the example, from this example, 96.7 divided by 100 equal to the 0.96967 meters. It is the first quantity we measure in this experiment. Later, we will measure the radius of the rod by using the vernier caliper. In the first, we should to screw the vernier caliper and keep the vernier caliper in the stanch line. And value you can read from the vernier caliper. It is the diameter of the rod. You can see the main scale and the scale vernier. The main scale of this vernier is the unit in the millimeter. You can see that the one scale of the vernier equal to the 1 millimeter. For example, you see the 0 rod on the vernier rod. 0 on the vernier rod is the position of the 3. It means that you can read the 3 millimeter of the main scale. And scale vernier, you can read that. You can see from the vernier, the one scale of the vernier scale equal to the 0.002 millimeter per one unit. You can see from this case, you can read the value of the vernier scale equal to the 0.14 millimeter. So you can read the vernier scale when you measure the diameter of the rod. It's equal to, for this example, 3.14 millimeter. This is the diameter of the rod. You should change you should find the radius. It means that you should divide the diameter of the rod by 2 and get the radius of the rod. And change the unit from millimeter to meter. In the next, we will measure the radius of the pulley or the wheel. Its value R using the outside caliper. Since we cannot using the ruler to direct the measure the radius of the rod, because you cannot line the ruler. Isn't that you should use the outside caliper to determine the radius of wheel. How to use the outside caliper? You see the outside caliper. In the first, you should attach or put the end of the outside caliper and to the fixed outside caliper on the first surface of pulley or wheel. But the another side, you choose to the slide as much as, and the position to the outside caliper can be light as much as This is the value of the diameter of the wheel or pulley. And in the next, you should line the outside caliper on the ruler and read the value. The one side of the outside caliper, please start from the 0 cm on the ruler and read the value to the another side of the outside caliper. For the example, you can read the value of the diameter is equal to the 14.3 cm. This is the diameter of the wheel, and don't forget divide by 2 to determine the radius of the wheel, and divide by 100 to change the unit from centimeter to meter. Okay. In the next, we will do the set 0 angle of the wheel to measure the twist angle. You should rope the wheel by the strip, okay, in the direction this direction, and to the hanger. You can the hanger piece the hanger to hang the wheel. You can see on the wheel. On the wheel, there are the main scale and the vernier scale rod. How to set 0? We should set 0 before take the rod mass to determine the twist angle. You want to the 0 on the vernier scale. This is a line in the same position on the 0 on the scale on the wheel. You should move the vernier rod. Don't move the wheel. To move the vernier rod to the 0 position on the vernier rod, take the same position on the 0 on the wheel. When you have the set 0, we should take the mass. You put the first mass is equal to the 100 grams. Change unit equal to the 0.1 kilogram. It means that you take the mass. It means that you take the external force to twist or the shear our rod, this rod, and read the twist angle beta on the wheel. The method to read the twist angle is the same the method of the read the value on the vernier caliper, but you see the vernier scale on the rod. You can see that on the vernier rod there are 10 scale. It means that the precision of the vernier rod of the angle equal to the 0.1 degrees. Before the experiment, you should make sure that the 0 on the vernier rod is the same position on the wheel. And when we take the mass, the 0.1 kilogram mass, you can see for the example, you see that on the main scale, you can read the 10 degrees. And you can see on the vernier scale, you can read is the 6 scale equal to the 0.1 multiplied by 6 equal to from the vernier scale equal to the 0.6 degree. Is that for this value of this rod mass, you can read the twist angle equal to the 10.6 degree. So we add the mass into the 0.2 kilogram and read the twist angle until the last value is the 0.7 kilogram. You can see that I add the mass 0.4, 0.5, 0.6, 0.7 until 0.7 kilogram. You can read that for this case of the 0.7 kilogram. You can see that the 0 on the vernier scale is the line in the position in the same of the zero on the wheel. This this case, you can read the twist angle equal to the 85.0 degree. After that, you should reduce the mass, but you can see in the case of the 0.7 kilogram, you cannot reduce mass. It means that the twist angle is the case of the adding and reducing mass of the 0.7 kilogram should be the same value. Later, you should reduce the one mass and again with the twist angle. So we should you should find average value of the twist angle when you adding the mass and reducing the mass. You use the average angle to plot the graph. So we reduce the mass from the 0.6, 0.5, 0.4, 0.2 and read the twist angle every time until the 0.1. For the example of the data, there are the twist angle when we add mass and reduce mass. You see that the value of the at the 0.7 kilogram is the same value because we cannot reduce mass at the 0.7 kilogram. So we can read the value twist angle until 0.1 kilogram and find the average angle, and using the data which we have determined. So we change unit. For example, change it from centimeter to meter and millimeter to meter, and you see that the zero reading is equal to the 0 degrees. 0 degree. After we collect every data, you should plot the graph. You plot the graph in the same way I have described in the part of the theory, and we determine the modulus of the rigidity. So after we finish experiment, should release the screw and take the rod, okay? And you should repeat this experiment for the case of the steel rod. And you should read the twist angle and the plot the graph and define the modulus. It means for experiment you find modulus of rigidity of the brass rod and the steel rod. Okay, finish experiment. Thank you, everybody.